Let's talk through the steps of this problem, okay? How long has it been since you've done a problem like this?
A hot minute.
8th grade? At least 3 years?
Like the other day.
The other day?
Yeah.
Normally, most people that have this problem come up like in this class, they just grab their calculator,
Yeah.
right? Okay, they don't have to do this by hand. I need us to talk through the steps to do this by hand because it's directly related to what we're doing today. Okay? So what do I think about first?
Square root.
23 going into.
So how many times will 23 go in, right? That's what I'm thinking about. Do I say how many times will 23 go into 1? Well, I mean, I think about that first, but I also know it doesn't. How many times does 23 go into 14? It doesn't. How many times does 23 go into 149? Oh, it will, right? So I have to try to figure this out. And again, we're not messing with our calculator, so let's try to use our brain. What if this was 150 and this was 25? How many times would 25 go into 150?
Twice.
6.
6? You're not wrong. It does go in twice, but it actually goes more than that, okay? It goes in 6 times. So do you think 23 going into 149 would be at least close to 6? And we'd have to think about it. Is it going to be above or below? And I think 6 is going to work just fine, okay? So where do I put the 6? Does it have to go there? It doesn't, right? It doesn't, but it helps us. That's a help, right, for us to put it there, okay? Now, what do I do with that 6?
You gotta multiply by 23.
I got to multiply it by that 23. So what is 6 times 3? 18. Carry my 1. 6 times 2? 12 plus 1, so 13. Did I make a good choice with 6? Excuse me, did we make a good choice with 6? Yeah, no, what do I do now? I subtract. Can you tell that my subtraction sign is a different color? Okay, that's on purpose. I think you'll see why once we start in just a second. It's not required, but you know I'm a visual learner, right? So I put my subtraction sign in a different color on purpose. Okay? What is 149 minus 138? 11. Am I done?
Now you bring down the 2.
Bring down the 2. Okay. Now what?
Now you find how many times 23 goes into.
Okay, so what if this was 25 and this was 100?
Go 5 times. Or 4 times.
4 times? Does it make any difference that now that this is 23 and this is 112 is still going to be 4, you think? Or is it going to be 5 or 4? Okay, so where do I put the 4?
Next to the 6.
Next to the 6 above the 2, right? And what do I do with the 4?
Multiply by 23.
Multiply. So what's 4 times 3? 12. What's 4 times 2? Plus my 1. 9. And now what do I do? Subtract.
So that'd be 10.
Try one more time.
20.
20.
So that'd be 10.
So when I go to write my answer, what I actually get from my answer is 64 and 20 23rds.
What?
Because
Yeah, I forgot about that.
hey, you heard me still talking, right? I was about to explain it. Yeah? No panicking, right? 64 is the answer I got. 20 is what? My remainder over what I was originally dividing by. Yes? Any questions? You know how to do this, right? You've done it a lot before. It's been a while, to be fair, but we've done this before, right? So now what our problems are going to look like today is this. Is our first step to panic? No, it's not. It is not. Our first step is not panic. That's the opposite of our first step. Our first step is not panic. Okay? The first step is we have to set the problem up. X minus 4. And underneath our division sign, x squared plus 8x plus 1. Now, I learned something recently that honestly I don't care about. I just thought it was a cool fact. So I'm going to share that cool fact with you. This sign, what do you call this sign?
Division bar.
That's what I call it too, right? It's a division sign, division bar. It actually has a name. Vinculum. That's the name of it. Now, do you care about that? No, but wouldn't that be a great extra credit question on a test? Yeah.
I have a question.
Please ask me.
Can we put the slash for the division sign? Or does it have to be the
Right here?
above? Sorry.
No, this is just how the problem is given to you. This is what you're given.
Okay, so I can put the slash.
Guess.
Okay.
It's the same thing, right?
Yeah.
Okay. So when we start this problem, we don't have to worry about trying to figure out what this goes into like we did on the other problem that I showed you. What we have to do is just look at the first term and just look at the first term. Okay? Before we do that, I'm going to take a quick commercial break. You ready for a commercial break? Think back to the last couple days that we've been talking about this. Think about the rules that we've been talking about. If I have x plus 2x, what does that equal? 3x. Because when we are adding, we only add the coefficients and we leave the exponents alone. Remember that? What if we have x times x squared? What do we do with the exponents when we are multiplying like bases? And remember, there's an imaginary 1 right here, so I get x to the third, right? Well, what do you think we're going to get when we have x squared over x? If when I multiply like bases, I add the exponents, what do you think that I do when I divide like bases? That's exactly what I do. I subtract exponents. What is 2 minus 1? So I get x to the first. Another way to think about that is x times x. Isn't that x squared?
Yeah.
Divided by x. What does x divided by x equal?
Nothing?
This is kind of a big deal, so I need to make sure you understand this. What's anything divided by itself? 1. That's 1. What's left? 1x or x. See how we got the same answer when I did the problem a slightly different way? Yes? This is going to come into play a lot today, so I need you to understand that x divided by x is 1. You got it? Okay, so now let's go back to the show. Okay, what is x squared divided by x? X. Where do you think I ought to put that x? Number 1 doesn't matter. It does not matter, but what it makes sense if I put it above its like term. Okay? This is going to come into play in a second as a helpful thing. Okay? So I'm going to put it above my like term. What do you think I do with this x now? What did I do before? What did I do with this? I multiplied, right? So do you think it would be logical that we multiply now? What is x times x? X squared. What is x times negative 4? Negative 4x. What do you think we do now? We subtract, right? Isn't that what we did over here? We subtract. Okay? Now, again, I'm using a different color because I'm going to put my subtraction sign. But let me ask you this. If that's the only subtraction sign I put, am I going to remember to subtract over here? So I'm going to subtract each term. But if I subtract a negative number, what's happening? I'm adding. So are you okay if I say that to say subtract? Yes? Okay. Now what? I combine, right? X squared minus x squared. 0. Okay? Guys, if I get anything else besides a 0 right here, I've done something wrong because my whole goal is to get a 0 right here. Okay? What about 8x and 4x? Try one more time. Just 12x, right? When I add like terms, I don't mess with the exponents. Remember that? Okay? And now what do? Bring down the 1. And now I kind of start over again, right? 12x divided by x.
That's 1.
It's 12, right? I'm going to write it for you. 12x divided by x.
Oh.
What happens with the x's? They simplify to 1. What's 12 times 1?
1.
12.
Wait. Did you? I think you said 12 divided by 1.
I did not. I said 12 times 1. But even 12 divided by 1 would still be 12.
Yeah, it's
Yeah.
Wait, I thought you said. Sorry, I thought you said. My brain.
I just think maybe you didn't know what I said, but you like to answer, and that's okay. I promise it's okay. Okay? So we said 12x divided by x is 12. Where do I want to put the 12? Above the 1. Okay. What do I do with the 12 now? Multiply. What is 12 times x? 12x. What is 12 times negative 4? How about negative 48? Does that work as well? Now what? Subtract, subtract. 12x minus 12x? 0. 1 and 48? 49. Now what?
x plus 49.
Or so are you saying I'm done?
No.
First of all, can you divide 49 by x? No, nothing will simplify, right? Okay. Also, is there any more spaces up here in the above my vinculum? No, I know I'm finished. So I got to write my answer. X plus 12 plus 49 over what I was originally dividing by, which is x minus 4. What is this called? Do you remember? This one? This number? That's my remainder, isn't it? Okay. My remainder is divided by what I was originally dividing by. It didn't like divide evenly, so I have a remainder. Okay? In this particular problem. You ready to try another one? So is this one harder? Why do people think it's harder? It's got more exponents. Does that mean it's automatically harder? No. You guys are so funny. Hilarious. Set it up. What goes outside the vinculum? X minus 1. Then I draw my vinculum. X cubed minus x squared minus 2x plus 8. Okay so far? So now I start. Divide the first term on the inside by the first term on the outside. What is x to the third divided by x? X squared. Where do I want to put that? Above the x squared. What do I do with that x squared? Multiply. What is x squared times x? X to the third. Good. X cubed. What is x squared times negative 1? Negative 1x squared, or negative x squared, right? Now what? Subtract, subtract. X cubed and a negative x cubed? 0. Negative x squared and x squared? Did I do something wrong?
That's the answer.
Oh, that's the answer? We don't have any more stuff? Yeah, we're not done, are we? Bring down the 2 and then bring down the 8 as well. Because I don't know what I'm going to need, so I just bring all the rest of it down, right? Negative 2x plus 8. What's up? This one right here? I'd said x cubed divided by x.
Oh, okay.
So, excuse me, x cubed divided by x. X cubed divided by x is x squared. Because 3 minus 1 is 2. Why is the x squared above its like term? Does that help you answer your question? We want to put it above its like term, right? So that's why I put the x squared above the x squared, because those are like terms. Okay? Again, that's not required, but it's helpful. Okay? Now what? Divide the first term here by the first term here. What is negative 2x divided by x? Please put it away. What is negative 2x divided by x? Negative 2. Where do I put that? Above the 8? So if I put it above the 8, what's going above the 2x? Is that okay? It's okay that there's nothing above there? What if I felt like I needed to add something above there? Could I? I could have been 0, right? I can't add just an x term, because if adding the x term changes the value of the whole problem, right? But if I just needed a term above that, I could put a 0x, couldn't I? Okay? I don't need to, so I'm not going to. But what do I do with the negative 2? Multiply. What's negative 2 times x? Negative 2x. And what's negative 2 times negative 1? Positive 2. And now, subtract. Negative 2x and positive 2x? 0. 8 and negative 2? 6. Guys, do you see how putting stuff above its like terms helps us? Because if I would have put the negative 2 here, I would think that there's another step to go. Is there another step to go? Can I divide 6 by x? No, I cannot. Okay? So now I write my answer. What's my answer? Could I have written a 0x right here if I wanted? Yes. Okay. Any questions so far? Set it up. X squared plus 4x minus 2. And what am I drawing? What's it called? Vinculum. Okay, what goes underneath it? Okay, so far? Where do I start? Just first terms, right? What's x cubed divided by x squared? X. Where does it go? Of the 10. Okay, the 10x. Okay. What do I do with this x? Multiply. What's x times x squared? X cubed. What's x times 4x? 4x squared. And what's x times negative 2? Excellent. Now what? Subtract, subtract, subtract. X cubed and negative x cubed? 0. 7x squared and negative 4x squared? 3x squared. 10x and 2x? 12x. And then bring down the 6. Negative 6, right? Negative 6, okay. Now what?
Divide.
First term by first term, right? Divide 3x squared divided by x squared. 3. Okay, before I even go on any further, what do I already know? That's my last step, right? That's my last step. I still have some work to do, but I'm not going to have to divide first term by first term anymore, right? What is 3 times x squared? 3x squared. Now do you see why I put like terms above like terms? It helps us know when we're done. Okay? 3 times 4x and 3 times negative 2. Okay? And now subtract, subtract, subtract. What'd you say? Oh, we panic now? No, that's like way easier, isn't it? I don't have a remainder this time. That's 0, that's 0, that's 0. What's my answer? Just x plus 3. That's it. There's no remainder this time. It's just x plus 3. Okay? How are you feeling about this? Here's why I ask. I have 2 more examples that I can show you, but I have to show you at least one of them. So do you need 2 more examples, or do you just want 1 more example? 2? Okay, I'm going to do 2 then.
Why had two of like
Okay. So let's do this one.
Oh my god.
X squared plus 3x plus 2 divided by 2x squared plus 2x to the 4th, excuse me, plus 3x to the 3rd plus 4x squared plus 5x minus 1. Because it sounds a little bit like you're panicking. You should not be. We should panic just when there's lots of stuff. So I should panic when you guys come in here every day. Oh my gosh. I'm not saying I don't. I'm just saying this is not what should happen, right? Okay? First term divided by the first term. 2x squared. Where does it go? So 2x squared. Multiply. 2x squared times x squared. 2x to the 4th. 2x squared times 3x. 6x to the 3rd, right? 2 times 3 is 6. And then x times x squared is x to the 3rd. 2x squared times 2. 4x squared. Subtract, subtract, subtract. What do I get? 0. What do I get? Negative 3x cubed. 0. Plus 5x minus 1. Do you notice how I left a space? What is that space for? The x squared term, right? Okay. Start again. Negative 3x to the 3rd divided by x squared. Negative 3x. And it goes above its like term, so it goes above the 5x. Okay? What do I do with the negative 3x? Multiply. Negative 3x times x squared. Negative 3x times 3x. Negative 9x squared. Guys, if I had not left the blank here, where would I put my negative 9x squared? Nowhere, right? So make sure you leave that blank when you need to leave it blank. Could we have written 0x squared to make ourselves feel better? Yes. Negative 3x times 2? Negative 6x. And now, subtract.